Today we're going to cover pages 4 and 5 of your Chapter 1 notes. Chapter 1 notes, Section 1.4. Today we're going to solve absolute value equations. Actually, we're going to do inequalities. Yesterday we did equations. So an inequality is when you have a greater than symbol or a less than symbol, less than or equal to, greater than or equal to. It's not an equal like yesterday. And when you have a problem like this and you're asked to find the solution set to this, that means that you're going to go through the process like you did yesterday, following the same, pretty much the same 3 steps with one little difference. Here's the given example, and I've written it down here. So the first thing you're going to do is you're going to, well, first of all, isolate the absolute value. Make sure it's all by itself. And this one it is, so you don't have to go through step 1. But on step 2, you're going to make 2 arrows like you did before, a left hand and a right hand arrow. And on the left, you're going to remove the absolute value bars. You're going to switch the inequality. This is a greater than. You're going to switch it to the left, to less than on the left, and then you're going to negate the number on the right. This is a positive 7, you just make it a negative 7. So over on the right hand side, all you have to do is remove the absolute value bars, and then if you have, in the original problem, if you have less than or equal to, you're going to write an and in between these 2 statements, or if you have a greater than, you're going to write an or in between these 2 statements. In this first example that I give you, you're going to have an or in between them because it's greater than. Sometimes we use the trick greater. I know that's not how you spell greater, but sometimes it's confusing whether you put an or in between the 2 or whether you put an and. So I say, oh, we're going to do greater than. So that's where the or comes from. Now when you continue to solve this, all you do is add 3 to both sides. And 2x is less than negative 7 and 3 is negative 4. Divide both sides by 2 and you get x is less than negative 2. Or now you're going to add 3 to both sides over here and you get 2x is greater than 10, so x is greater than 5 when you divide both sides by 2. So you have 2 parts of the solution set. The solution to the above inequality is x is less than negative 2 or x is greater than 5, exactly what we came up with in the end. So you can put that on the answer blanks down here. Now when we do inequalities, solutions to inequalities can be represented 3 different ways. The first way is a symbolic way, and that's how you have listed it here. Symbolic, the root word to symbolic is symbol, and the symbols, inequality symbols, are those 4 inequality symbols, the root word symbolic. Now there are a couple of other different ways to represent these. One is called an interval notation, and if you look at the last 2 pages of this packet, pages 11 and 12 of this packet, it explains to you, I hope you've seen interval notation before, but if you've forgotten what it is, you can just read through those last 2 pages and it'll explain interval notation. And you're going to have, sometimes you're going to have infinity and negative infinity symbols in these in the interval notation, and you can see that in a second. Graphically, on a number line, so if you have a number line, you're going to put the 2 solutions, and you're either going to fill in the circles if you have greater than or equal to or less than or equal to, and you're going to have open circles on the number line if you have strictly less than or strictly greater than. So in symbolic form, the solution to this problem up here is, we're going to write it again, x is less than negative 2 or x is greater than 5. We're using symbols. These are the symbols. Now in interval notation, what we're going to do is we're going to use the open parentheses, not the square bracket, because you use a square bracket if you have less than or equal to, greater than or equal to. And if you just have just plain old less than or greater than, you use the rounded parentheses. And that's what we had in this problem, is just a plain old less than, plain old greater than. So everything that's less than negative 2, the lowest number we could go to, well, we couldn't get there. It goes down to negative infinity, and it goes up to -2. So this part of this solution set is written in interval notation like this. All right. Now in OR, you can write the word OR if you want to, or what we usually do is we write a little U. That stands for union, and x is greater than 5 means we're going to start with the number 5 and we're going to go all the way up as high as we can possibly go. We actually can't get there. We go to infinity. So this part of the inequality is represented in interval notation like this. So those are the two parts and their union together. Now if you want to graph the solution, all you have to do is put the two important numbers on the number line, the two important numbers being -2 and +5. You're going to have open circles. I like to put my open circles above. You can put them right on if you want, but it's really clear if it's above that they're open. And less than goes to the left. So you're going to draw it this way, and greater than goes to the right. So you're just going to shade to the right here. And that's the three different ways: symbolic, form, interval notation, and graphically. So this is like 1, 2, and 3 different ways that you're going to represent this solution. Okay, we're going to practice on a couple more problems here. Now what we have here is a less than. So this is going to be a little bit different solution than the previous one. But we're going to still set up with a left hand and a right hand arrow, and the absolute value is already isolated, so we don't have to worry about that. So we're going to put 2x plus 3 without the bars. We're going to change the less than to a greater than, change the 49 to a -49. Now if you have a less than, you're going to put an and in between instead of an or. And then over on the right hand side, we're going to have 2x plus 3 is less than 49, just the exact same thing without the bars. And then we're going to just go ahead and solve this like normal. So you're going to subtract 3 from both sides, and you get 2x is greater than -52, so x is greater than -26. And when you subtract 3 from 49, is you get 2x is less than 46, so x is less than 23. Now when you have an and, what we're going to write is a single inequality. So the ands will go together into one. And the one inequality will look like this. You're going to have the lowest number, which is -26, and then you're going to have a less than x, because x is greater than -26 is the same thing as -26 is less than x. Those are saying the same thing. And then you're going to have a less than the bigger number. So when you have an and, when you have a less than, we call this is a trick. I just say this is less than, T-H-A-N-D, less than. And that's just our little trick to remember that it's an and ands have to be written into one single inequality like this. In symbolic form, you're going to write it -26 is less than x is less than 23. And in interval notation, we're still going to use rounded brackets because it's just plain old less than, not less than or equal to. You have -26 all the way up to +23. And then graphically, -26, +23, you have two open circles, and you're going to shade in between them because we're talking about all the numbers in between -26 and 23 being a solution. So if you just select any number in between these two, put them into the original inequality, you'll see that it'll turn out to be true. On part B, we don't have to isolate the absolute value because it's already isolated. So on the left-hand side, we're going to put -1/3 x plus 14. We're going to change the greater than or equal to less than or equal to, and change the 18 to -18. And over on the right, we're just going to remove the absolute value bars. And this is a greater than, so you're going to put the word or in between. Now just as normal, you're going to subtract 14 from each side, and you get negative 1/3 x is less than or equal to negative 32, or, oops, let's just continue and solve this. To get rid of a negative 1/3, you're going to multiply by the reciprocal. The reciprocal of negative 1/3 is negative 3, so we're going to multiply both sides by negative 3. So negative 3 times negative 1/3 is just 1. So you're just going to get x. Now remember, when you're multiplying or dividing by a negative number, you're going to have to switch this inequality symbol. So write this note down in your notes when this says multiplying or dividing by a negative. You're going to have to switch the symbol. So instead of less than or equal to, we're going to turn it into greater than or equal to. And negative 32 times negative 3 is going to be a positive 96. Now over on the other side, we're going to subtract 14 from 18 and get negative 1/3 x is greater than or equal to 4. To get rid of a negative 1/3, multiply both sides by negative 3. So you're going to get x is less than or equal to, because we're multiplying by the negative 3 here, so this has got to switch. X is less than negative 12. So this is an or, so we're going to have two parts to this inequality in symbolic form. And usually you write the smaller one on the left, the smaller one being negative 12. So I'm just going to put x is less than or equal to negative, whoops, got to make sure that's a negative 12 in there, or x is greater than or equal to 96. Oops, that's the symbolic form, because you're using symbols. In interval notation, everything less than negative 12, well, it goes down to negative infinity, and it goes up to negative 12, and because it's less than or equal to, you're using a square bracket, then put a little u in between for the union, and x is greater than, oops, I wrote this wrong, should be 96. So greater than 96, you're going to start with a 96, and everything greater than 96 goes all the way up to infinity. And on infinity, you always put a rounded bracket on, because you can never reach infinity. Graphically, what we have is a negative 12 on the left and a positive 96 on the right. This time we're going to fill in the circles because it's a less than or equal to, greater than or equal to, and if it's less than or equal to 12, we go in this direction. If it's greater than or equal to 96, we go in this direction. So there's the three formats. Now what I'd really like for you to do is to shut off the video right now and try to do these three problems on your very own. And then once you get them done, then you can turn it on and go through them and see if you've got them right. So go ahead and turn this off if you'd like, or you can just watch me if you want. All right. What we're going to have to do in this case is we're going to have to add 1 to both sides first, because we have to isolate the absolute value first, because it's not by itself. So we have the absolute value of x is greater than 5. So now we're going to do our two branches left and right. X is less than negative 5. This is greater than, or x is greater than 5. And that's all you have to do. There's no algebra involved in this problem at all. So symbolically, x is less than negative 5, or x is greater than 5. Interval notation, negative infinity, all the way up to negative 5 with rounded, and 5 all the way up to positive infinity rounded. And graphically, negative 5 to positive 5, open circles, and you're going to shade to the right, shade to the left. Less than is to the left. And there's the final answer in the three different formats. Now in this one, you're going to have to subtract 3 from each side, because you're going to have to isolate the absolute value. So you have the absolute value of 0.1x is less than or equal to 2.4. And now you're going to have the left-hand branch be 0.1x is greater than or equal to negative 2.4, and this is a less than, so you have an and in between. 0.1x is less than or equal to 2.4. Now, how do you get rid of a 0.1? Well, there are many different ways. Probably the easiest thing is to divide both sides by 0.1. And you can get your calculator out if you want to. But that's just the same as multiplying both sides by 10. So this should say x is greater than or equal to negative 24. And divide both sides by 0.1. You have x is less than or equal to 24. So in symbolic, oh, and we haven't finished this up because if you have an and, you have to write it as a single inequality. So you start out with negative 24, less than or equal to x, less than or equal to positive 24. That's symbolic form. Negative 24, less than or equal to x, less than or equal to 24. Interval notation. We have a bracket. You start with negative 24 and you go up to positive 24, square brackets. That means x is everything in between and including the 24s. And graphically, you have a negative 24, positive 24. The circles are filled in, and you're shading in between because you're considering all the numbers in between those two values. Now, which one of these inequalities has, this is a funny symbol, but this means the empty set, which means there's no solution. Which one of these inequalities is there no solution for? Well, if you run through these, the only thing that's really different about any of these, you can have values of x that are greater than 2. That's fine. You can say x equals 3. There are values of x that are less than 2. You can say maybe x equals 1, for instance. You can say any value of x here is always greater than negative 2, any absolute value, because all of the absolute values are always positive. So this is always true. You might want to take a little note. This will be always true for all values of x, and that's because absolute values are always non-negative or greater than or equal to 0. Now over here, can you ever have an absolute value be less than a negative number? This would be the one. This would be the answer to this question. Part D, this is never true. This has no solution, because absolute values can never be less than a negative number. They always have to be positive or 0. They must be, oops, can't even read that. I can't even read that. Must be greater than or equal to 0, just like I said over there. So the answer to this question, number 3, is letter D. There's no solution. You can never have absolute values be less than any negative. It wouldn't matter what it was, if this was a 0 or anything negative. There is no solution to this. You couldn't put any value of x in there and have that be a true statement. And that's the end of today. Have a great night.